No. I'm going to go ahead and start, even though it's not 3 o'clock. This is the Labview programming training session. And the stuff that I'm going to cover is the stuff that's up on the board. We talk about Labview, what it is, and where we find it, where we get it. And then I'm going to go over a few of the programs that we use: basic, begin, teleop, autonomous. And then the big one at the end, the one that everybody should know about, is how to deploy the program to the robot. This is not a comprehensive, full-blown session on Labview. This is what everybody on the team should know. And honestly, most of the challenging stuff in Labview, you just have to get into the program and work it yourself. Once you find out how the help file works, once you find out what's going on with the wires, you can figure a lot of things out yourself, test them. If it works, good. If it doesn't work, just go back and change the code. And that's kind of how the program runs. There's a difference in the great big world of programming between text-based languages and non-text-based languages. Text-based is just the words, line after line of code. If you've ever looked at the HTML behind a web page, you've seen text-based. If you've worked with BASIC, if you've worked with Java, any of these languages are text-based. And most of them are text-based languages that are out there. But there are a few that use these visual icons. And I'll show you what that is in a second. But it's basically a picture on your screen, an icon, and embedded within that is all the text-based stuff. So you, as the user, never get to play with the actual words. You're just moving these little images around the screen, connecting them one after the other. That's how Labview works. You either like it or you hate it. It's one of those things, there's no in-between. I was raised on text-based languages, so I hate it. But I understand how it works for the most part. Where it is for us, we now have our very own programming computer. This computer is dedicated to programming first robotics. It even says Team 2944 on it. It didn't used to exist. We used to be using one that was donated by one of the members of the team. So our program, Labview, will be on this computer. We have a temporary license with National Instruments, the people that make this program. It's renewed every year. So it lasts for 365 days. It drops off almost exactly the day that we get the new updated version. It's always reverse compatible, so all of our old programs will work on next year's version of Labview. It's never been an issue before, so kind of like it's a renewing contract, if you will. Once we get the kit of parts at the start of the build season, one of the things that's in there is a folder that we keep for the rest of the year. It looks like this. And it has that year's version. We load that up on the computer, we upgrade. It's kind of a pain in the butt because you've got to go through the internet to have it activated. But once that's done and you update your libraries, you're good to go for the rest of the year. So this is what... Yeah, go ahead.
I need to get Cody's laptop because we need to go down to the gym to test.
Okay. This is what the icon looks like, the Labview 2012 icon that's up there now. Once you see that on the screen, it's like any other program. Click on it, open it. And there will be some intermediate screen here, like this. So once again, launch Labview. This year's version has a slightly different user interface, but we work with what are called projects. A project is like the folder that you would have in my computer where all of those files are kept in that one folder.
Leaders, it's time for TLC in room 131.
It's like that, so I click on it to open it up. And this happens a lot. There are so many files involved, and a lot of times you have to wait. This will be one of the short waits. The longer wait is when we launch any one of those programs. This won't take long to load. while it's loading, Labview provides us with a full version of the program necessary to run the robot. It's extremely basic. It's simple. To the point of being simple, but there's no way in heck we could develop that on our own. We have to have that starting point. There are layers after there's multiple layers behind these programs. So we're going to open up the top layer right now. It's called Basic Main, and it's right here, Robot Main. So after this, after I selected the project, this is known as the Project Explorer. We'll have to come back to this to talk about deployment. But RT Compact Rio, the C Rio, is the brain on the robot. So this is the code that's going to go on there. We're looking for Robot Main. This is the top level. The top level of the layers of program. We should never modify this particular layer. But it's really good to look at because it explains what's going on, big picture stuff. Doesn't look like much right now, because this, one of the features of Labview, is that it has two screens to choose from. This screen is called the front panel. It's the same thing as a GUI, graphic user interface. Like the desktop back here is the graphic user interface for Windows, for example. This is where you set up your GUI for all of your programs in Labview. You have constants that you can put in. You've got buttons to start things happening. For the camera, for example, the camera image would show up on this front panel. But for our purposes, we don't use this. So we have to skip beyond this and get to the code that's underneath it. There's a couple of shortcut keys that you have to learn if you're going to work with Labview, and one of them is Control-E. I just did Control-E. That last screen was known as the front panel. This screen is known as the block diagram. Every single program that we're going to look at, and every single program that exists, has a front panel and the block diagram. Most of the programs have a blank front panel, absolutely nothing on it. It's only if you add something in that it will be there, an indicator. But they all have the block diagram because this is where the code exists. This is called the robot main. It's provided to us. We don't have to develop this, thank the maker. It's all here for us. And the advice they give is don't mess with this. This shows big picture what's happening for your robot. And let me go over a couple things here. First, on the left, the documentation. You can provide text to explain all of the things that you're doing. This is not programming code here. These are just word comments that are put in to help you understand what's happening. Second, you see these strange shapes here that have the blue and the red. Those are actually programs, entire programs on their own. You don't see the code within it. But when I double click on any one of these, it will open up that code so that you can see it. The idea is, why clutter up this particular program with that additional code when you don't need to see it? It can just be represented by this one link that's here. So when I click on any one of these, I go down a layer. This is the top layer, and we go down a layer from there. The advice is, do not mess with any of this. When we make changes, we will open up this second layer down, and that's when we will make our changes. Okay? The second thing that you notice is there's a bunch of these thin wires. It seems like these icons, they're called VIs. VI means virtual instrument. We just say VI. These icons, these VIs, are connected to things. The wires have meaning. The thin wires pass data. So there's information that's actually output from this particular program that is needed later on. If an icon is just sitting in space, it will execute. It will run when you select this program to run. But if there's no input or output, nothing will happen. There has to be some way of getting the information out to the next part. And you can see there's different types of wires. The thin wires tend to be data wires. The thicker wires tend to be sequence. If you've got a bunch of things on the screen and they're not connected, the program will execute all of them simultaneously, pretty much simultaneously. If you want one to happen after the other, you've got to actually put them in order. So begin, and then it goes to this big thing over here. Get mode, and then it goes in here. If you don't have the sequence set, the program will just assume you want them all to run simultaneously. The next thing you notice is you see more of these comment bars here, more comment bars, but there's this great big gray box here. This is what's known as a do loop. In text-based languages, you would say do, and then end, or loop at the end, and it would continue going over and over again until the end condition is met, then it stops. So if you've got a task that you want repeated continuously until some condition is met, this is how you do it. You put it inside one of these gray boxes. This is a do loop. The end condition is marked by the little stop box that's here, little stop sign. And as it is right now, you see a gray line going in there. You can't see what's going to cause this to stop. Inside of this loop, you've got your VIs. You can see your VIs. You've also got these blue boxes, which are constants. So not a program, not a function, just a name. You have to have those names in there, and the program has to know what you're referencing. You'll create that, and we'll talk about that when we go to the begin. You create those links in the begin section. Then you've got other ones that are different colors. If it's green, it tends to mean Boolean, which is true, false, binary, ones and zeros. The different colors, different meanings like that. All right, I think I'm ready to talk about this structure that's on the inside. You notice that this gray box holds things. So everything that's inside the gray box is repeated in a loop over and over again. The same thing is true for this hatched line. This is an if-then. It's called a case structure. It's an if-then statement. Here's how it works. If teleop enabled is the case, it will do this thing. It will do teleop. But as soon as that happens, it will do this thing. And as soon as finish happens, it will do this thing. So this is an if-then. If this is true, do the stuff that's in there. If the other one is true, do that stuff. And there's no limit to the number of conditions that you can put in there. I stopped on the finish for this reason. Finish is its own VI, its own program. But notice over here, the T means true. If this is true, it wires to the stop sign. As soon as the condition is met for the stop sign, guess what happens to the do loop? Okay, that wasn't a rhetorical question. Guess what happens to the do loop? It stops. So this do loop won't stop until the finished condition is met. See how that works? It will just keep going until the finished condition is met. How are we doing so far? I'm not going to show you how to change things in this one because we don't want to change this. We should never have to change this particular part. But after this, we talked about these other things, we can make changes to the next layer down. This is where we want to make our changes. When we as programmers are going to change things, we always save a copy. Keep the original pristine, unchanged. We had that issue the first year when we lost our original program because it had been modified too many times. We always save a copy of the original out-of-the-box program and make changes to our copies. Yeah.
Is there no online copy of the original program?
Not to my knowledge, because it's provided in the initial update. When we load next year's version on, we will update it. And I went through that today because I was trying to find the original program and couldn't. This isn't quite the original program. I had to make some sacrifices to get it to look like it. And I'm going to look at the begin. And all I did was I clicked on it. I just clicked on it. Let me X out of that so you can see it again. So one click, and all of a sudden it's this dash thing here. Click it twice, quickly, and it opens up. It always goes to the front panel first. Remember, we don't really care about the front panel, so you're just going to have to go through and Control E each time, and then it'll get to the block diagram. So this is where we can start to make changes. And this is where we will have to make changes if we add any equipment to the robot that the robot's not expecting. We've got to tell the program that's a servo. So that when the signal comes in through the wires, the program says, oh, that's a servo. And it knows what information to send back, what information to take, and what information to send back. So we have to do what's called reference. And you can see some of these reference numbers, ref nums. where it's put in is PWM, pulse width modulation. These would be for, well, these would be for servos actually. So these would be for servos and also for motors. So you have to tell it what exactly you're going to put in there, and that's created here and put into these programs. So this is another VI. To make changes to a program, I'm going to carefully move my cursor up here. You can see in the upper right hand corner. And when I right click anywhere in the block diagram, the functions palette comes up. This is, if you like this kind of programming, this is really the advantage to this kind of programming. Let's go with, why not just do this? You can select the icon. Ooh, let's do LiDAR. That's fun. You can select the actual thing that you want to put on your screen, and you click it and drag it onto the screen. That's all you do. So you don't have to write out the word-for-word text. It already exists. I don't know what a Hoku URG is, but I'm going to drag that out here. I think I am. Put it somewhere else. Let's do one that's easier. Click, drag, release, and there it is. Now, that will execute. When you run this VI, that will execute. Since there's no wires going in or out, it'll execute and nothing will happen. You need to have inputs. Inputs come in on the left and the outputs go in on the right. Information goes in on the top and the bottom as to what it is. So the question then becomes, well, how do I wire this? If you have to learn how to wire something like that, remember the first hotkey I told you was Control E. What does that do?
Bring up the bottom thing.
Control E
Yeah.
goes to the block diagram underneath the program, right? Good. And then the next one is, and this one's easier to remember, Control H for help. Control H is a very powerful feature of this program. If your cursor is over that thing and you don't know what all these wires are for, most of them you don't need. But you're going to at least need to have inputs and outputs. So if you don't know what those are, you put your cursor over that block and then it tells you up here what it is. And usually you can scroll down and find more. Write to spreadsheet, so this is not something we would ever need. But the options are there and it tells you exactly how to wire it, what information will need to be wired. Control H, possibly the most important thing to remember. I'm going to delete this because I don't want it. I'm feeling something else is there. The other thing to notice here, I saw one somewhere, yes, we've been talking about these VIs, these virtual instruments. Virtual instruments have the bright colors on them, and it tells you, if you look close enough, what exactly it is. And I told you about the constant boxes, and I told you about the information, and I told you about the wires. When you see something like this, it's not a box, it's some other shape, any other shape like that. What this is a function. Not quite the same thing as a VI. A VI is an entire program, a self-contained program. You click on it, you can see what the program looks like. You don't really care, so you collapse it back down so that it's just a little box here. This is a function, like adding, subtracting, comparing, listing, whatever. So it's not the same thing as a full VI, but you will need that to perform operations. So just like the VIs, it has inputs coming in. It's comparing. That looks like a router number, 192.168.0.90. So it's comparing this to whatever's happening. Oh, this is for the camera. It's comparing it, and then it outputs. If the condition is met, it outputs that into the camera VI here. So the two types of things that you will find on Labview are functions and VIs. Those are the two most important things. Both of those are listed on the functions palette, which remember, I right-click anywhere I want, and there it is. Okay. You remember I told you about the while loops, I told you about the case structures, they're all here. And plenty more to choose from. Alright, so there's lots of things to choose from, structures, functions, easy calculations, multiply, subtract, add, all those things are there. You just have to put it on the screen and wire in and wire out. Different types of numbers, if you want constants, all this stuff, you get this from the function menu. Honestly, we don't use much other than the stuff that's down here in robotics. When we get our full library from first, All the stuff that's related to the stuff we will use in the kit of parts is down here. But, you know, occasionally you will have to add a while loop and you will have to do some sort of comparison. That does happen. Okay. I think I'm done with the begin VI. The basic idea in the begin is just you're going to want to, and notice there's a lot of stuff out in space that's not connected. So you are just identifying the equipment that you're using on your robot here, because it will be referenced later in other parts of the program. If it doesn't exist here, when you talk about it in another part of the program's not going to understand what you're talking about. So the Labview project will always go back here to find out what is this talking about. That's the main purpose behind begin. So we will have to modify this. For some reason it went off the screen. Way off the screen. The next part, don't save. I don't want to save. The next one that I want to show you after begin is the teleop. Again, when teleop is enabled, when that condition is met, the loop is running teleop. Teleop means you are driving the robot with the joysticks. That's what teleoperated means. So this is most of the match. There's 30 seconds at the beginning for autonomous, but this is really the most important part of the match. As such, you might need to make changes to teleop. It's woefully jumbled and confusing here, but the important thing to remember is you need to make sure that your joysticks are wired correctly, and this is where you do it. Button 1 and button 2 refer to the joysticks. So this is where you will go to change if you're going to do a different kind of drive. If you don't want to do whatever the tank drive, the normal tank drive, if you want to change this to arcade drive or a different kind of drive, you can make that change by replacing that VI, and then you just rewire your buttons here. You tell it which button does what, and then the information will flow. So teleop is where we will go to make our changes to the drive system. When we decide on 4 wheels or 6 wheels or 1 wheel, I don't know, and the number of motors to drive those, we will go ahead and make those mechanical changes, and then we've got to follow up by making the changes here. That's all teleop does for us. If we have this set, we can drive the robot any way we want with the joysticks. Any type of joystick. Okay? So that's teleop. Let's look at autonomous. Autonomous is the first. Where's autonomous? I couldn't get. Autonomous is the first 30 seconds match. No, this is driver station. But the autonomous is also something that we have to create from scratch, which might be why it's not here. Autonomous is not a requirement for the first robotics competition. The first 30 seconds of the match, you can have your robot sitting there quietly minding its own business while other robots are doing their thing. Autonomous means completely hands-off. So the robot is either pre-programmed to run a route, or it's using its sensors, taking in information, deciphering the information, and responding to it. Those are your options for autonomous. But since it's not required, they don't provide you with an autonomous program. You have to create it from scratch, and this obviously doesn't have it. But once we created that autonomous program, it would go in here. Okay? So this is the place really where the elite teams are separated from the average teams. The elite teams have people that can make really good autonomous programs. It's only 30 seconds. But the way they do it for this points, they tend to give more points for anything that's accomplished during the autonomous, during 30 seconds, because they know it's more of a technical challenge, more of a programming challenge. So yeah, you'll see a lot of the teams just sit there for the autonomous. Others will try to do something simple like drive forward 3 feet, shoot some frisbees or something like that. That's what we did. And then others will actually use their sensors, and those are the ones that score big points. But we will be free to modify that one. That's the autonomous. Other ones that are on here just depends on what you do. If you're going to use your camera, you're going to have to access the vision, for example. And that's another VI that you can make changes to. we have not been successful. We've been moderately successful. We've not been too successful using vision for a sensor. We've used the camera just so that we can see what's going on, but there's lots that you can do with that hasn't been done yet. All right. Let me make sure I've covered everything I wanted to cover, and then we'll talk about how to deploy it. Good. 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 Okay, we're ready. Let's say we've got our program set. This is what everybody needs to know how to be able to do. I'm going to close it. It's going to ask me to save. I'm going to say, no, don't save. So we go back to this stage, and you should remember how to get here. From the Project Explorer, you'll notice that it's got all this stuff. We want to go down to this last line that says Build Specifications. And we click on that, and you see right there, FRC Robot Boot Up Deployment. Now, at this stage, we would have the robot in the room. We would have a Cat5 cable going from the computer into the C-RIO, into the brain. Top part of the C-RIO looks like this. Has modules in it, Cat5 cable. I don't remember which one it is, but it's one of these two Cat5 plugs that's right here. We plug the Cat5 cable in. Everything is turned on, waiting. Once everything is turned on, waiting, we can right-click. Got a couple choices. If we're just messing around to see what's happening and we don't want to disconnect the Cat5 cable, we can select Build. But assuming we've got our program ready to go, and we don't want a Cat5 cable connected when we're running it out on the floor, we go down to the Run as Startup. This takes the program and permanently, well, semi-permanently, places it on the brain here. So now all of that code is locked into the computer chip on the C-RIO. Now, when you disconnect, it's already there. Every time you turn on the robot, it's going to start that process. It's going to start running the code. That's what we want, Run at Startup. So we will select Run at Startup, and then you hope there's no problems. There's always problems. It seems like every time we try to do this the first time, Run at Startup, it goes through those same, it's downloading files, and it comes up with these little things that say, hey, you're all messed up here, you've got a problem with this, and then you got to go fix that. So there's a lot of troubleshooting at that stage where you got to go back and find out what went wrong. But once you get that done, you're done with the program. Questions? Okay, then the last thing is this. The actual people that are driving it, when they go and open up the computer, you'll have a choice between the developer and the driver side. The driver side, for the drivers, is the GUI, the graphic user interface. So it's basically a front panel that looks a lot nicer than that gray field. But it has all the information about how to drive the robot. It'll tell you if there's communication. It'll tell you if the sensors are working. There will be a camera image if you'd like to see what the camera is looking at. All that stuff is there. And that GUI is a lot more user-friendly than the ones I showed you, the front panels here. It's designed for the drivers, not for the programmers. So they should, and always are, able to work out how to drive the robot straight from the driver's side on the laptop. Okay? Overwhelming? Hope it's not too bad? Just a little? Okay. Until you play with this, until you've worked with it for a while, yeah, it's going to seem that way. The good news is it's all digital, so as long as you're working off a copy, make a mistake, who cares? Just get rid of that copy and go back to your original, right? That's the nice thing about it. Okay. Any other questions? Yes?
Why doesn't the robotics team use text-based programming?
The programmer that we had here for 4 years was kind of raised on this, number one. Number two, National Instruments, the people that make Labview, are possibly the largest sponsor of FIRST Robotics. So they've had their fingers in this from the start 20 years ago. And third, because the program is provided complete, ready to go out of the box, we tend to favor it. Now, Java, at least Java, I've been told, Java and maybe one or two others have started doing that where they provide a ready-to-go, out-of-the-box program for FIRST Robotics. I've been told. I don't know that for sure because I haven't tested it. But since everybody, it's one of those Darwinian selection things. You know, everybody started with Labview. It's the most common one out there. And since it's so common, it's most likely it's going to last while the others drop off and die out. But since it's so common, if we have a question, if we're not sure what's going on, it's easy for us to get on the phone and call another team, because the vast majority of teams are using this programming language. Whereas if we were using C++, we'd have to call a long time to find a team that was doing this in C++. You know, and that's the only reason. It's a matter of convenience. This, and I don't want to downplay this. I mean, Labview is, in the industry, Labview is used all over the place. This icon-based, visual basic type stuff is used everywhere. This is the industry standard for a lot of things, way beyond robotics. Way beyond robotics. It's used in industry and it's used in research at the universities. It's a very common program at the higher levels. It's worth learning, in other words. Other questions? Yes?
Have we ever used sensors on the robot before, other than the
Yeah. We did do, we had a line follower type setup, and it didn't work very well, so we took it off, but we played with it during a build season once. We tried to make the camera into a sensor. That didn't work very well. Beyond that, not really, no. But that's something that we really love to do, because it can help. Sensors can be finicky. You got to get the right sensor. It's got to be durable, because these things get hit. I mean, there's a lot of impact. It's got to be durable, and reliability is an issue. But if you find the right sensor, yeah, it's definitely a plus. Other questions? Okay, there's probably a little more than an introductory lecture, but does everybody understand how Labview works, the basics? The stuff that we can do. Don't go too far down. Those layers I told you about, if you open up Teleop VI and clicked on any one of those, it would open up another program. They don't really structure this so that you need to go down in the weeds like that. You should be able to make all your changes at that first level below the main. All the changes you're going to do should go there. If you're getting down 2, 3, 4 layers down, you've gone too far. And there could be other consequences as well, because those lower layers aren't just being referenced by the program you're interested in. Those lower layers are referenced by all the programs. So you make a change down there, it has a cascade effect across all those higher level programs that you might not anticipate. So it's better to go shallow when you're talking about changing the FRC program. Not the top, don't do the basic, but begin, teleop, autonomous, these are the ones, camera, vision, these are the ones you can mess with. Okay. Okay, are we done? Thank you.